At first, this problem screams brute force.
But with one smart trick, you solve everything in linear time. Sounds impossible? It's all about a tiny trick with prefix sums, and once you see it, you'll never forget it. Want full solution? Check this video.
Hi everyone and welcome back to the channel. Today we are solving a really interesting problem from LeetCode called sum of distances. Let me quickly explain the problem. We are given an array, and for each index we need to calculate the sum of distances between that index and all other indices that have the same value. So basically, if a number appears multiple times, we compute how far each occurrence is from the others. So for example, here we are given the nums array that have these values. So for index 0, we need to calculate how far the value 1 from the other indices that have the same value 1. So here when I equals 0, and we have num of 0 equals num of 2 and num of 0 is equals num of 3 because all of them have the value 1. So we need to return an array at that index, so at index 0, that have the distance between index 0 and index 2 and index 0 and index 3. And this gives us the value of 2 plus 3, which is 5. Now, the brute force approach is straightforward. For every index, we check all other indices with the same value, and then sum up the absolute differences. That works, but it is slow. And in worst case, it becomes O of n squared, which is not acceptable for large inputs. So how we optimize this? Here is the key idea. Instead of recomputing distances again and again, we group indices by their value. For example, here we have num that have these values. And let's focus now on number 1. Number 1 appears in indices 0 and 2 and 3. So we group indices by value. For the value 1, we have the indices 0 and 2 and 3. And we do the same for the other values. Now comes the smart part. We process each group separately using prefix sum. We do two phases. First phase is from left to right, and the second phase is from right to left. And in each phase, we keep track of how many indices we have seen so far and their total sum. And for each position, we calculate how far it is from all other previous position. If you still didn't get it, let's have an example. Let's first here have phase 1, which we iterate on the array from left to right. So at index 0, or before that, for each index, we need to calculate two things. The first thing is the prefix sum, where we accumulate the indices in each group as we iterate over them. So this is accumulation. And the second thing is the contribution so far, which means the distance or how far our index from other occurrence of other indices that have the same value. But let's first understand how we calculate the contribution. We have two types of contribution. We have left contribution, and this is a contribution when we iterate over the indices array from, or indices group from left to right. And we have the right contribution. And this is the opposite when we iterate over the indices group from right to left. So imagine that we have an array of indices or a group of indices that looks like index 0, 1, 2, 3, 4, and so on, and then x, and then so on, and so on. So let's imagine that we are currently at index k. We are iterating again from left to right on the group of indices, and currently we are at index of x, and there are k indices before it. So we need to calculate first their sum, the sum of all of these indices, and add this to the prefix sum. We add all indices till x, and the contribution, say the left contribution, will equal uh, the indices that we need. As we said, we are currently at element x, and we have, let's say, k indices before it. So let's name them a1, a2, a3, a4, and so on till ak. And what we need here in this question is to calculate the how far our element or index x from other elements. So need to calculate x minus a1 plus x minus a2 plus x minus a3 plus and so on until plus x minus a k. And if you factor this equation, it will equal k multiplied by x minus a1 plus a2 plus a3 and so on plus a k. And this addition equals our prefix sum, so that will end up that our left contribution will equal k multiplied by x minus our prefix sum. So this is for the left contribution. For the right contribution, we almost need to do the same, but now we have k element after x. So what we need to do is to calculate the distance between, but this time from a1 minus x plus a2 minus x and so on until we have ak minus x. And again, if we factor this, it will have the value of a1 plus a2 and so on until ak, and this minus k multiplied by x. And again, this value will be equivalent to our prefix sum minus k multiplied by x. If you still again didn't get it, let's walk through an example. So again to our nums array and focusing on number 1. So here at index 0, no element, at index 0 in this group, no element before it. So our prefix sum will equal to 0 and our contribution, let's name it L contribution, cont for abbreviation, will also equal 0. So that will add 0 to our result, final result from the left to right iteration. And again, let's name it index 0. And at index 2, the second index here, we have seen one element before it. So the prefix sum here, the prefix sum here will equal 0 plus 2 equals 2, and our left contribution will equal 1 multiplied by 2 minus 0, and if you didn't get it, 1 is equivalent to the k, because we have seen only one element before index 2, and 2 is the current element, so this is our x, and 0 is the prefix sum. So let's calculate the contribution before the new prefix sum, or this is the old prefix sum, so it gives us the contribution of 2. So now we have the contribution, the left contribution array equals 2. And finally, at index 3, so far we have seen two elements before the current element. So now k equal 2, and the current element is x equal 3, because we are at index 3. And the prefix sum, the prefix sum is 2, so our left contribution will equal 2 multiplied by 3 minus the old prefix sum, and this will give us the value of 6 minus 2, which is 4. So this value will equal to 4. So this is the final left contribution, or distance left contribution. So let's name it the left distance contribution. Now we will go to the other phase, or the other path, from right to left. And again, we will reuse our prefix sum. First, we need to reset our prefix sum to 0. And now we will iterate from right to left. So at index 3, the contribution is 0. The R contribution will equal to 0, and the prefix sum will equal, the new prefix sum will equal 3, because we don't have any other element. Let's move this here. And again, at index 2, we have one element to the right. So the right contribution will equal, and let's make the distance contribution here, it will equal 0. And the contribution will equal the old prefix sum minus 1, which is the k here, multiplied by 2, and this will give us the value of 1, and the new prefix sum will equal 3 plus 2, which is 5, and again we add our contribution here, which is 1, and at index 0, here at index 0, we have two elements to the right, so the k will equal 2 and the x will equal 0. So our right contribution will equal 5 minus 2 multiplied by 0, and that will give us 5. So let's name this one the distance right contribution. So here we have the left distance contribution and right distance contribution, these arrays, and if we combine them together, it will give us the values of 5, 3, and 4. And this is exactly the contribution, as you can see here from the output, 5, 3, and 4 for the value 1 in the nums array. So this solution avoids nested loops completely. So in summary, we group indices by value first, group indices by value, and then we use prefix sums. We process left to right and right to left, and finally we have efficient solution in linear time. So not to make this video so long, I'll copy and paste the solution because it is exactly the same to what we have explained here in this video. As you can see, first we define the variable to get the nums size in a variable n. Then we define the contribution vector that will hold the final result at the end, also of size n and initialized to 0. We defined a hash map that will be used to store the value and its corresponding indices. This is maps to this step. So for value 1, we will have a vector that hold all the indices that have the value 1. And this is how we do that. We loop over the nums array, and for each value, we push its index. For each same value, we push its index. And then we process each group. And for each group in our hash table, we process from left to right. We reset our prefix sum initially, and then we calculate the contribution as we have seen in the example below. It will equal the k elements. This is how element we have seen so far multiplied by the current element, and then we subtract the prefix sum, and then we calculate the new prefix sum. After that, we do the second phase, which is processing the array from right to left. Again, we reset our prefix sum, calculate our contribution, also based on the formula we have seen, which is the prefix sum minus the the k, because we are moving in the different direction, multiplied by the current element, and also updating the prefix sum with the current value. And finally, we have the result combined in the contribution array. And this is all for today's solution. Before moving on, let's run it and submit it. And if you found this helpful, please don't forget to like and subscribe. And if you want the full code, check the description below, and see you in next video. Thanks.